Hello friends, welcome to Truth of Physics. Today in this video I will discuss on electric field lines, flux and Gauss law. In this video I will discuss all the topics, the concepts, the inner concepts and some very important things related with these topics I will discuss in this video. So this video will be very helpful and very important for all of you. So we all know the expression of electric field intensity. What is this? E vector is equals to 1 by 4 pi epsilon 0 or q by 4 pi epsilon 0 into 1 by r square r cap. Okay, we all know this. Where r is what? R is the r cap is the direction, right? And r is the radial vector or position vector. So if we want to draw the electric field lines, so what will be that? Because from this expression we can understand that the electric field lines will be, if we want to draw, so the electric field lines will be just radially outward, because due to this q charge, the electric field intensity E vector, the relation in the electric field intensity E vector due to this positive charge q, it is directed radially outward. From here, from this expression we can easily understand this, that the electric field lines are radially outward for this positive charge q. So if we have positive charge q here, so the electric field lines will be like this, radially outward. Okay, now one more thing is, from here in this equation you can understand that electric field intensity, the magnitude, I am taking only the magnitude, is directly proportional to 1 by r square. That is, as we move away from this charge, then the electric field lines will decrease with 1 by r square, 1 by the distances square. Then so I can draw the electric field lines for some far region from this charge, like this, some small vectors with some small vectors. Okay, some small vectors. Why some small vectors? Because we all know that the vector in vectorical form, the length of the vector represents its magnitude and the arrow represents its direction. So as in this region or in this spherical area, suppose you have to imagine, suppose we have a positive charge. Okay, think it, you have a positive charge and the charge is emanating electric field lines radially outward from it. So what will be that in 3D space? This will, if we take a certain distance r from the charge, then it will be a sphere like a football. So it will be a hollow sphere, and we are considering the surface of the sphere, the surface area of this sphere. Okay, I am just denoting this. This is not a circle, this is a sphere in 3D case. So at each and every point on this sphere, the electric field intensity will be same, because r is same and it is directly proportional to 1 by r square, and as r is fixed, so E is also fixed or also constant for all the points on the surface. And so from this surface, from this point, the electric field line is like this. Okay, this vector is represented with this vector, electric field line vector or force of lines. Now if we consider a big spherical shell or sphere, then on our new sphere's surface, that is on this surface, each and every point on this surface, the electric field intensity is also same, but is less than of this, because the distance is now greater, and as distance is greater, E will be less. So we are drawing this small electric field line vector, because here at this point, the here at this point, and this point, all these points, the electric field intensity is decreased. Okay, it is clear. So in this way we can draw the electric field lines. One more way to draw electric field lines is like this. Electric field lines can also be drawn like this. Why this? So let us understand it. Here you can easily see that the differences between these two figures, that here I have drawn different length of vectors to represent electric field lines, but in this picture I have drawn uniform lines, okay, for representing electric field lines. So what is the reason behind that? So understand it, let us understand it. So this expression can also be expressed like this: E vector is equals to q by epsilon naught into 1 by 4 pi r square into r cap, right? I can write like this. Now from here you can understand that, think it carefully, that it is what? Area for a distance r, a spherical area 4 pi r square of a sphere of radius r. So this is area, and this is our electric field, and this is a quantity q by epsilon naught. We don't know what is this. We will later understand what will be this. We will establish what will be that. Okay, we are approaching in that direction. So let's start to understand. So this is our area of that spherical shell. So we can understand that electric field vector or electric field intensity is something divided by area, that is something per unit area. Okay, something, that is this, something per unit area. This means as there is, this is in the denominator, so we can understand that something by this means per unit area, something per unit area represents our electric field. Okay, we have understand it. Now you can easily see that from this figure, as the distance increases from this charge, the electric field lines is decreasing, right? So the electric field lines in this region will be greater than of this region. It is clear. Now you can also watch on one more thing, that from here in this region, imagine just in this region, this imaginary sphere, this is our imaginary sphere. In this spherical area, the number density of electric field lines, that is electric field lines density, electric field line density is greater than of this big sphere. Why? Because you can easily understand it from your common sense, that here this is our big area and the number of field lines are same. Here in this big area, the number of field lines passing out from this area is what? 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. So this is 6. Number of field lines, total number of field lines emanating from this bigger sphere is 6. So number is 6. And from this small area, let us calculate this. So from this small area, the number of electric field lines emanating is 1, 2, 3, 4, 5, 6. So these are same. So the number of field lines is same, and so the density, number density of field lines, number density. So the number density will be what in both the cases? So the number density here will be what? 6 by a big area, right? And here in this case, the number density will be what? 6 by a smaller area, because this is a smaller area. So you can easily understand that this value will be greater than this value. That means the number density in this region will be greater, and we have just understand that electric field lines in this region is also greater than this, than of this. So you can just relate these two things. As the number density, the electric field line density, electric field line number density or electric field line density increases, the electric field also increases. as the electric field line density increases, the electric field is also increases. That means we can also relate this from here with this. Okay, now we have one conclusion, that is electric field lines or electric field intensity is proportional to electric field line density. Electric field line density. And from here you can easily watch one more thing, that here electric field line is some quantity per unit area, right? Some quantity per unit area. Here we have understand that it is proportional to number of field lines per unit area. It means density. So from here and here you can understand that this unknown quantity q by epsilon 0 will be what? Must be equal to the number of field lines. So q by epsilon 0 is equals to number of field lines passing through that imaginary area. So now the electric field intensity will be what? The definition of electric field intensity will be the number of electric field lines per unit area. This is the number of electric field lines we have just established from this and this. This is the number of electric field lines per unit area is denoted with our electric field lines. So this is the physical concept of electric field lines. Okay, number of field lines per unit area. Now from here we can easily write one more thing, that is E dot, or in magnitude form, if we write in magnitude form, then E into 4 pi r square is equals to what? Q by epsilon 0. Q by epsilon 0 is the what? The total number of field lines. So this is our total number of field lines. So this will also be our total number of field lines. As the right hand side represents the total number of field lines emanating from an imaginary surface of sphere, then it will also be the total number of field lines emanating from that sphere of radius r. Okay, and we all know that what is this? This quantity is known as the electric flux. So this is known as electric flux, and in the form of vector calculus we can also write this like this: E dot ds, right? Integration over a closed surface. So this will be our closed surface. So this will be equals to q by epsilon 0, and this is what? This is our so-called Gauss theorem, or Gauss law. Now we can also establish this from here. Okay, I am just establishing this. E vector is equals to E dot ds. Okay, we want to find E dot ds, right? Now in spherical polar coordinate we will apply here the spherical polar coordinate to write the ds. And we all know that in spherical polar coordinate what is our ds? ds is r square sine theta d theta into d phi. We all know this, and the direction is r cap in spherical polar coordinate. I think you all know from the concept of curvilinear coordinates that in spherical polar coordinate this is our small surface element ds. Okay, and E vector is what? 1 by 4 pi epsilon 0 or q by 4 pi epsilon 0 into 1 by r square into r cap. So here is r cap and here is r cap. So and here is integration over closed surface. So this is a surface integral. So this will be what? R square will be cancelled out, and q by 4 pi epsilon 0, and here sine theta d theta. From this integration d phi, the integration of d phi will be just 2 pi, and from sine theta d theta this will be just 2. So after integration we will find that this will be equal to q by epsilon 0. So E dot ds is equals to q by epsilon 0. So it is proved the Gauss law. Okay, this is our Gauss law. Okay, now one more another thing to understand is, for each and every sphere, for big or small, whatever may it, but for each and every sphere, our imaginary sphere, the electric field lines, the total number of electric field lines that is denoted with q by epsilon 0 is constant. That is, the total number of electric field lines emanating from this surface is also equals to the total number of electric field lines emanating from this surface. So from there we can understand, it can also be understood from here that this is constant, q by epsilon 0, and E dot ds may change, E may be changed. E means what? E means q by 4 pi epsilon 0 into r square, right? So E may change as r varies, okay? E may change and ds may also change, but here you can see that r square and r square is cancelled out. So the E dot ds, the flux is not dependent on the distance, as this is cancelled out just, and this results out a constant q by epsilon 0. So whatever may be the sphere, whatever may its size, but the total number of field lines which is denoted with this q by epsilon 0 emanating from that surface will be constant. And from here we can easily understand that previously I have also discussed this, that this is 6, the total number of field lines emanating from this this sphere, and from this sphere it is also 6, the total number of electric field lines. So from this concept we can easily say that whatever may be the surface, okay, whatever may be the surface, this is not mandatory that this surface would be a sphere, the surface of a sphere, whatever may be the surface, but the electric field lines, the total number of electric field lines spreading out or emanating from this sphere, arbitrary shaped sphere, will be what? Q by epsilon 0. If q is fixed, if the charge inside this sphere, inside this surface is fixed, then the total number of field lines coming outward will be just fixed or just constant. So for you can relate this, that in the definition or in the expression of Gauss law, you use this, that whatever may be the surface, or if we have an arbitrary surface. So it is just clear that we have not mandatory that the surface should be a sphere. The surface should be, the surface can be of any shape, any arbitrary shape, but this rule will be always followed, okay? E dot ds will be q by epsilon 0. Now from all of these discussions, I think that you have also understand one more thing, that electric field lines is also related with the charged enclosed or the charge, okay, that is the q. So how it is, let us understand. Suppose this is a charge, okay, this is a amount q charge, okay, and the field lines are emanating from this charge, and suppose this field lines, yes, the field lines obviously be equally equally separated, or the distance, this distance must be equal, this distance and this distance, okay, but it is not possible for me to draw like this symmetrically, okay, symmetrically outward. This field lines will be symmetrically outward, okay, the distance, all the distance between each and every field lines will be same, okay. Now if here from this charge q, the number of field lines emanating is 1 2 3 4 5 6, this is 6 number of field lines emanating, then if we have a charge 3q, okay, or if we have a charge 2q, then what will be the number of field lines emanating from this charge? That will be just the double of this, that is q is directly proportional to field lines, number of field lines. So if we have a picture like this, that q charge, and we have a q charge and the field lines is, number of field lines is 6, then if we have a 2q charge, then the number of field lines coming outward will be just 12, okay. So this will be just, I am just drawing this, so the total number of field lines will be just 12 for 2q charge. Likewise, if we have a multiple, if we have nq charge, then the total number of field lines coming outward will be just 6 into n, okay. So I think that you have understood all the concepts, and I think that this video is very helpful for you to understand the core concepts. Share this video more and more to your friends, and if you are new to this channel, then subscribe this channel and hit the bell icon for getting the latest notifications of my upcoming videos. So take care of yourself. Thank you for watching.